In section 3 of chapter 3, we're going to be factoring polynomials. We just got done in section 1 with using area models to multiply. Section 2, we did that process in reverse, so I had a full area model filled in. This is directly related to that, but with factoring, we're still doing that process. What you will find is there's going to be critical pieces of information missing from our area model, and you're going to have to figure out how to piece it together. It's kind of like Sudoku. All right. Quick review, recap of what we just got done doing. We would have a binomial times a binomial, x plus 8 times x minus 3. We would draw an area model and go, all right, fill out the outside with a x plus 8 and an x minus 3. And then we'd multiply to get the interior areas. X times x is x squared. X times 8 is 8x. X times negative 3 is negative 3x. And then negative 3 times 8 is negative 24. These diagonals are the like terms, so I can combine those together to get my final answer of x squared plus 5x minus 24. And this is my answer. Yay. What we're doing today is the exact same problem, just in reverse. So it's going to start off with giving you the multiplied out equation. Our goal is to find the original two binomials whose product is that trinomial. So we're going to need an area model. And here's how this is going to be different than what we did yesterday. The first term goes in the top left portion of the area model. The last term, the negative 24, goes in the bottom right portion of the area model. Here's what makes this different than the last lesson. We don't know what goes in these two boxes. What we do know is whatever ends up in these two boxes is going to have to combine together to get us a positive 5x. That's our only hint as to what those two values are. Now this problem is not too difficult, but it's still a bit of a challenge. Lastly, because this is negative, I know that whatever number goes here and here are going to be opposite positivities. One's going to be negative, one's going to be positive. That means the numbers in these two boxes are going to be opposite positivities. That means I'm looking for two numbers that have a difference of 5. All right, so let's start filling this in. Now, because the top left portion of the area model is x squared, I know this needs to be x and x. I'm going to pretend like the red equation doesn't exist. I'm going to go through this like I would normally. I know that the number that goes here and here have to combine to get me 24. So what I do is I list off all the possible products that give me 24. 1 times 24, 2 times 12, 3 times 8, and then 4 times 7. Thank you. All right, one of those sets of numbers has to fit there. So I would try the 1 and the 24. That would give me a 24x and a 1x. Those two do not have a difference of 5. So I know that the 1 and 24 do not work. So I cross that off my list. Then I do the 2 and the 12. That'll get me a 2x and a 12x. Those do not have a difference. Remember, we're looking for a difference of 5. So 2 and 12 also do not work. Then I'm going to try 3 and 8. Put the 3 here and the 8 here. That'll get me an 8x and a 3x. Those two do have a difference of 5. The only way I can get a 5x from them is if the 8x is positive and the 3x is negative, which means the 3 is negative and the 8 is positive. Last check, positive 8 times negative 3 is in fact negative 24. I have found my answer. It is x minus 3 times x plus 8. I want to go through two more problems. These are different for multiple reasons, but the biggest one, the most straightforward one, is the leading term has a leading coefficient. That x squared has a 2 in front of it. The second x squared has an 8 in front of it. That's going to throw some stuff off. Specifically, problem number 1 is a little bit of a doozy. All right, 2x squared goes in the top left box. 15 goes in the bottom right box. I know it's got to be a 2x and an x. You could also swap their positions, but at this point, because I don't have the other two positions on the outside of the area model filled in, right now where the x and the 2x go is kind of arbitrary. I know it has to be an x and a 2x. Numbers that multiply to get me 15 are 1 and 15, and then 3 and 5. When these two terms are different, not only do I need to try the 1 and 15 in this position, I would also need to check them in their reverse position. I'd also need to check if the 15's up here and the 1 is up here. I'm looking for those two boxes to have a sum of 8. That's the middle term. All right, so if I have it in the configuration it is currently in, I would get a 15x and a 2x. Those will add to get me 17, so that doesn't work. All right, now let's try the 15 on the bottom, the one here. That'll get me a 30x and a 1x. Those would add together to get me a 31x. That's not the 8 that I need in the middle, so that doesn't work. I've tried both configurations of the 1 and the 15. Neither of them work, so now I'm moving on to the 3 and the 5. I'll put the 3 here. I'll put the 5 here. This is a 10. This is a 3. Those would add together to get me a 13x, not the 8 I'm looking for. So that configuration doesn't work. I'm going to put the 3 here. I'm going to put the 5 here. That's going to give me a 5x and a 6x. Those combine to get me an 11x. Therefore, 3 and 5 don't work. This is one of the reasons I actually like the area model, is because you're literally checking off the numbers you've already assessed. And once you're out of numbers, it's not factorable. The other techniques, some of them do, but a lot of them do not let you know when the problem cannot be done. You just kind of get stuck in a loop or get stuck at a wall and you just feel like you can't actually finish it. When the area model will actually tell you once you run through all the numbers, there's no numbers left, so you're done. It's not factorable. Problem number 2, that has a different issue. Area model. I'm going to put the 8x squared in the top left, the negative 9 in the bottom right, and whatever ends up in these two boxes is going to have to subtract to get me a negative 6. So it'd be something like a 10 and a 4. Now here's the thing that makes this tricky. 8 is not prime. That means I can't just plug the numbers in because I don't know if it's a 1 and an 8x or if it's a 4x and a 2x. So there are multiple options for that one. And there's multiple options for the 9. We have to try every combination of these values until one of them works. So let's try the 1 and the 8. Here's a 1x and an 8x. Now I'm going to try plugging these numbers in here and here in both positions until I get the numbers that I like. So I'll put the 9 here and the 1 here. That'll get me an 8x and a 9x. Those would have a difference of 1. I want a difference of 6, so that orientation doesn't work. Put the 9 down here and the 1 here. That gets me 72x and a single x. Those do not have a difference of 6, so those don't work. Therefore, 1 and 9 do not work for 1 and 8. Now I got to try 3 and 3. That's going to get me 24x and 3x. Those do not have a difference of 6. And because if I swap the orientation of the 3 and the 3, it'd be the same original problem, I know 3 and 3 don't work. Therefore, 1 and 8 will not work. Now I've got to try the 2x and the 4x. I got to start over. Got to try the 1 and the 9. Put the 1 here, the 9 here. That's 18x and 4x. Those don't have a difference of 6. By the way, a lot of this can be done in your head. I just want to show you me doing it on paper. 18x and 4x, they have a difference of 14x. I need a 6x, so that orientation doesn't work. Then I got to try putting the 9 here and the 1 here. That's a 2x and a 36x. Those don't have a difference of 6x, so that orientation doesn't work either. So I've tried the 1 and the 9 with the 1 and 8 and the 2 and the 4. That means 1 and 9 are definitely not it. Last one, this is the only one left, so if this doesn't work, it's not factorable. 4x times 3x is 12x. 2x times 3x is 6x. 12x and 6x do have a difference of 6x. They'll combine together to get me a negative 6x as long as the 12x is negative, meaning the 3 is negative, and the 6x is positive, meaning the 3 is positive. Therefore, my factored trinomial turns into 4x plus 3 times 2x minus 3. And this is my answer. Do not forget to actually write out the product of the two binomials. The area model, even though it has your answer in it, is not the answer. I need what I have boxed right here. Don't forget to do that step.